Okay, I got a story I'm going to tell you today. It's I covered it in my classroom a few years ago, and it was one of the more interesting stories when you're dealing with these automotive electronics. A lot of the times when you're thinking about how you're going to do some kind of work on, how these modules are talking to one another. You know about networking and CAN buses and all that kind of stuff. Well, the wacky thing about it is you don't always know how modules interface with one another, and that can be a peculiar problem. And so one of the things that I had dealt with is these shapeshifter vehicles, and they suddenly start giving troubles that you didn't expect. It just seems to come out of nowhere. And so here I was looking at this situation on this Buick that I was going to talk about here. And I think you got to remember about this Buick here is 23 years old, and even then it had boxes and modules and stuff like that on a really nice car. And there was a foreign exchange student that had paid about $2,500 for it. She was going to drive it for about a year and then sell it to somebody when she went back to Germany. And it was a really nice Buick. And so it came in there, and she was basically wanting some air. She wanted to be cool. We wanted to cool down and all that. And it had a low coolant light. The air conditioner wouldn't work. And I don't know if you're familiar with some of the low coolant sensors on these GM vehicles, but the low coolant sensor is basically just a square thing that goes into the radiator, so it's exposed to the coolant, and it'll have an electrode in there that, just like a brass rod that's exposed to the coolant, or maybe some of them I think would have two, but some of them just had one. And I was sort of interested in the way that those things work, but I never dug into it. I do know, though, that if you had not enough coolant or too much coolant in the mix, this light, it would turn on the low coolant light. But a lot of the times this coolant level sensor was bad, and we had to replace some of those. When we checked the coolant, it was okay, it was full. And, we looked at the mix, we used a refractometer to check that, and also we said, well, we gotta have ordered a coolant sensor, you may as well go ahead and do that. They didn't have one in stock, so we went right to work on the AC. And so what we did was we put some nitrogen in there, about 150 psi. You put too much of the dry nitrogen in there. If you put the pressure in there that's too high, you'll basically make a leak where there is no leak. And what I mean by that is you'll too much pressure, and you could, we got a regulator, just like a regulator. It was on here, just like an AC regulator, and we had it hooked up with the yellow hose on the gauges. And we would open this up, and then dial in that pressure at a level that was about 150 psi. I don't like going over 150 psi. Some of the other guys that use dry nitrogen to check for leaks might, but in this particular case, I did that because I didn't want to make a leak where there wasn't one. The last thing you want to hear is you blow something apart because you put too much pressure in there. Because there's a lot of pressure in a nitrogen bottle, and you can really kind of overdo it. Didn't find any leaks. We shot soap bubbles everywhere. Saw no leak of any kind. Figure we're going to put some dye in there. We put some dye in there. We put the proper refrigerant car charge in there, and this thing's blowing just as cool as a cucumber. But we know it's not going to last because it was atmospheric when it came in. Atmospheric means that it was completely, everything that was in it had leaked out and had been replaced with atmosphere. And so the pressure had totally equalized between the outside and the inside. Because it had probably been a long time since anybody put anything in there. The air conditioner was dead when she bought it. But she was going to bring it back the following week. This was the last job we were doing that week. And so I said, let's just check this out right quick. We'll go ahead and do this. So we sent her out of there and told her to bring it back the following week, and we'd look and see if any of the dye was going to show up where we could see it with our black light and all that. And so she come back on Monday. The low coolant light still red, but there now is a trunk ajar light. It wasn't there before, but it was a little bit annoying, to tell you the truth. We had the AC wasn't cooling anymore. Weren't surprised by that. It was going to lose its refrigerant charge anyway. The coolant sensor that we put on there fixed the low coolant light. That took care of the low coolant light, but we still had the trunk ajar light. So the black light showed the compressor was leaking. We had all kinds of greasy dye show up on the bottom of the compressor. That's really a fairly common thing on a lot of these GMs. A lot of the times the compressor is the most common leak point. We replaced the compressor. The orifice, which was really clean, looking at the orifice, you can tell if there's a bunch of stuff coming apart that's in the system, you know, that's got the orifice clogged up with crud. Sometimes you'll see Teflon strips from the seals in the compressor and all that kind of thing. This orifice was clean as a whistle. Then we replaced the accumulator, which is standard procedure when you're putting a compressor on it. You always need to put an accumulator. The accumulator don't cost very much if you know where to buy one, you know. If you've got a shop, you can do business with Ranshu, R-A-A-N-S-H-U. The folks that have everything done in pink, you know, kind of funny. But if you're a shop, you can buy AC compressors and accumulators from them. And, you know, they're headquartered in Nevada, but they got warehouses all over the country, and I used to buy stuff from them all the time. But like I say, an individual, if you don't have a shop, you can't buy from these people. You got to have a shop to buy from them. And from those people, you can usually get an accumulator for like 16 bucks or something like that. Now, the accumulator may be aggravating to change, but it still needs to be changed if you're on the orifice, and the accumulator need to be changed if we're putting a compressor on it, which we did. All right, so we got that ready. Well, it had become a shapeshifter. The compressor would not engage, even though we could engage it artificially, you know, by energizing the clutch, click, it'd come in. The PCM wouldn't turn it on. Furthermore, as we were running the thing, checking it, some of the people that the students I had there working with me said, you know, this thing here is showing like it's getting pretty hot on the gauge, and those fans aren't coming on. Now, granted, we had just put the coolant sensor on it, but it was full of coolant and burped out and all that kind of stuff. Thermostat was opening and closing and everything. So, what do we know for sure? Over the weekend, it lost compressor operation, it lost coolant fan operation, and it picked up this funky trunk-ajar warning. I mean, none of this stuff was like that when that vehicle left the previous, I think it was on Thursday when it left because we didn't have classes on Friday. But the simple fact was, between Thursday and the following Monday, it picked up these extra problems. All right, so now we're going to do a little detour. This 2002 Santa Fe had a dead air conditioning unit. These people had taken it to a dealer somewhere, a Hyundai dealer somewhere, and the Hyundai dealer had spent something like $3,000, $4,000 or something like that, replacing this, that, the other, the compressor, and who knows what all else. And these people were really disgusted, and they came and they said, if you can't fix this thing, we're going to trade it, because we're tired of spending money trying to get the air conditioner working. Well, we did this little button dance on the AC control head, and it threw a code for the evap temperature sensor. You push auto control knob and then pushing the off button at least 5 times within 2 seconds with the ignition on. The problem with that is sometimes it's aggravating to get that control head to respond to that and go into self-test mode. You can plug a scan tool in and get more codes, you know, and they're basically B codes, you know, but you're going to get these body codes. There's a whole pile of them. But the information that we got was all that we needed here, whether we had an open evaporator temperature sensor, and that's right here, and that was a code 17. See, it's only got those few codes right there that you can get through the control head if you can get it to go into self-test. Well, we managed to get it to go into self-test. All right, and so we went ahead and replaced that. That's like an 8-hour repair right there. It was a bear. But once we bought that $29 part, put it in there, the cool thing about that was whenever the guy that owned the vehicle came back and it was running, the air conditioner was running, it was freezing cold in there and all that, he was super, super, super happy. And he says, he got me over to the side and he goes, can I give the guy that did this work, I had one guy that worked on it just by himself, and it took him all day to get it done because it was a big job. Well, the guy says, can I give the student a tip? And I said, I don't care, you know, I mean, you can't give me a tip, but you can give a student a tip, you know. And so that guy opened up his wallet and he pulled out every $20 bill he had, and that was 8 $20 bills. He gave that student a $160 tip because he was so happy that air conditioner was fixed. I've often told people that if you fix somebody's air conditioner so that they're cool again, you're going to be their hero. It's just the way it is because people love their air conditioners, and we're going into summer right now, you know. All right, so the AC clutch didn't engage on the Buick. We're back to that. Coolant fans were inoperative. That was dangerous in the extreme. Trunk-ajar light. Now, you know, if you let somebody go with coolant fans not working and they're sitting in traffic, they're liable to burn that thing up. Particularly if it's a Chick-fil-A drive-through where they're going to be sitting there for a while, and the exhaust from the car in front is coming through the radiator and all that. So, could these 3 problems be related? The normally operated trunk-ajar switch, we basically had, I had some guys check that trunk-ajar switch, make sure it was okay, look at the circuits, you know. They didn't find anything wrong with that. So we put that on the back burner. The trunk-ajar light's not as big a deal as the coolant fins and the AC. The cooling fans are the most important pressing thing now because that's an engine killer. All right, so we held it overnight. I said, you cannot take this vehicle because I don't want you driving it and burning it up. See, if she takes it and drives it and burns it up, she's going to try to act like it was our fault. So I held on to it. Sometimes you got to hold on to a customer's vehicle whenever they might be a little upset about it because you got to protect them from themselves because all they know how to do is just drive that sucker. You know, I knew about one vehicle that this guy took in to a dealership to get it looked at for a cooling fan issue. It was trying to overheat. And whoever it was that was working on it was dingy enough to where they got caught up fixing an engine skip. And they put an injector in there and some other stuff and got it all straightened out where it was running real smooth. Never even addressed the problem the ticket was written up for. Told him it was fixed. Nobody checked it behind him, and they charged this guy $500 to fix the engine skip when they had never even looked at the cooling problem. So he drives the thing home and burns it up on the way home. And that was what he took it in there to get fixed, you know. Anyway, the cooling fan circuit on these GM cars like this one here are pretty doggone neat. Basically, and I'll show you how they work here in a minute. But you got 3 relays, and you got 2 switches in the engine controller. You got these 2 fan motors, and you got that one ground, right? You got that? Okay, so what you got here, I built this board with 2 fans, 3 relays, 2 switches, and I actually had little bolts coming through, you know, so that you know what you were connecting to based on the schematic, you know, each relay. And I would even give them a schematic, and I let these guys wire this up so that whenever you turned on that switch, both fans would run at half speed on 6 volts. And when you push this button, they would kick on and run full speed. And it basically gave them an understanding of this wiring, because that's the wiring schematic I would give them on how to wire that thing up. Okay, so what we needed to do was find the relays and determine which pin goes where. That wasn't that difficult. Using the schematic, you know, and going to the find the fuse panel details and, you know, which relay is what. And so what we wound up with, the cooling fan serial parallel relay was here, the cooling relay one was there, and cooling fan relay 2 was right there. Okay, now watch this. So that's cooling fan relay 1. This is a series parallel relay, and this is cooling fan relay 2 for high speed. All right, so watch what happens here. All right, whenever this fan, I'm gonna watch that in. This switch closes. All right, that energizes that relay. That relay sends power through this fan, and it goes through the normally closed terminals on the cooling fan relay series parallel. And so that power is having to go through both of those motors to make its way to ground. So you got 6 volts running each motor. You got a series circuit there. All right, so the fans are running in series. But when the fan gets ready to kick on high, the high speed, this one stays energized. That one, I'm going to go back. That one clicks on. All right, when that one clicks on, basically, and I didn't draw green on that, but the simple fact is, this relay now is energized. And so what you got now is you got this power that's coming through this relay. It's going to here, and it's basically carrying this, which I should have painted that green. And anyway, it's carrying this directly to ground. So you got 12 volts running this relay, because there's your circuit right there. The other one, that cooling fan relay 2, but basically when that one clicks shut, see that? It basically starts feeding power through that cooling fan 2 fuse directly through that one around. And so that's pretty darn cool the way they came up with on how to do that. It took a really good engineer to make that happen. But it's fairly common on GM. Not all cooling fans work this way. So you need to be aware of the fact that, you know, this one you can understand it really, really well. That's the one I modeled my fan trainer board on over at the college. I guess they still use that over, I don't know. But how we test these fans, I want to make sure these fans are okay. You can pull the fan out, and you can put it on the bench, and you can wire a test light in series, you know, hook one of those terminals on the fans to the ground on the battery, and from the positive side of the battery to the other fan terminal, you put a test light or some kind of a light, so that you turn the fan through. If there's a dead spot on the commutator, the light goes out, and that's how you know the fan's bad. Well, how are you going to do it in the car? All right, what we did in the car was we removed this relay, took it out of here, so we had an empty socket here. From the positive side of the battery, to the terminal that was going out to this, and we basically have got both of these. We're checking them both that way. Pretty slick, huh? So you turn that relay, and you turn that motor, and see if that light ever goes out, right? Because if it does, you know, then you know that you've got a bad fan motor right there. Well, while that light's on, you can't, you know, if it does have a time when it's going out, you got to move the motor to the point where, I've seen fan motors have only one good commutator segment. I've seen that on a PT Cruiser that I was checking the fan on that was overheating. Anyway, this one here, while that one's got the light turned on, you're going to move over here and move this one and see if it goes out. That's the way you can check them both. But you're going to have to work with both of them. If this one here is at a spot where it goes out, you obviously are not going to see any light at all on this one, so you got to move that one so it comes on. You got to play with both of them. But once you get this one where it's on, you turn that one. Once you get that one where it's on, you turn that one. And if either one of them has a segment that goes off, you got to replace the fan because there ain't no fix for that. All right. Anyway, with the scan tool, after we did this check, we told the PCM to turn the fans on, and it turned them on both speeds. So the PCM knew it could turn on the fans, and that told us. Now I will tell you that the fans can have a dark spot on the commutator, and you may never find that unless you turn it through with the light connected like I do, because it's like roulette. It may stop every time on a good commutator what you got in the service bay, and if it stops on a dark place when they're setting at a traffic signal down there, you know, the pop off on the AC may blow because the condenser pressure goes too high and all that. Anyway, now that we knew both the fans were good, which we verified that, we disconnected the ECT sensor, and the PCM would also activate the fans at low speed. A lot of vehicles will do that. Toyotas will do it too. You unplug the engine coolant sensor, the fan comes on at low speed just by default. But if it doesn't know what the coolant is, it's going to run the fan just to be sure. All right, of course, you're going to have other trouble too if you leave it unhooked for that reason. All right, so now we knew we had no issues with the PCM driver circuits, relays, or the fans. We've already eliminated all that because of the way we've gone about this. The PCM had the ability to operate the fans because we turned them on with the scan tool on both low and high speed. But for some reason, it was choosing not to do it on its own. The PCM was even reading the ECT correctly. Look at it as a scan tool, you can see the ECT was accurate, but it wouldn't activate the fans. So how could we fool it into turning on the fans by making it think the engine was hot? I love the potentiometer trick. You can use this thing for all kinds of stuff. You get you a potentiometer, it's like a 50,000 ohm. It's got to be the window in which your circuit's going to be operating anyway, your sensor or whatever. But if you connect this in place of a sensor, whether it be a light sensor or anything like that, you can dial in the voltage you need to see if the circuit's going to work if the voltage is right. Because this is basically going to be a substitution. It ain't hurting a doggone thing. You're not going to burn anything up this way. So we disconnected the ECT sensor, put a 50,000 pot in there, just hooked to these two. You can hook to those two or these two, but the middle one is going to have to be one of the ones you're hooked to. You don't need to be trying to hook it to the two outer ones, or it's just going to be a fixed resistance. So you want it to be hooked to the one that's going to change, right? All right, so let's take this out of here, move it out of the circuit, and we're going to connect this to that ECT signal. We're going to be telling it lies about what the sensor is, because we want to see if that engine controller will respond to a high temperature and turn the fan on. You're able to do this without heating the engine up, so there's no danger of burning anything up, if you understand what I'm saying. You can trick the engine controller there. When you're turning this knob, you're going to feel the engine speeds change and all that, because it actually is going to do other things besides just operate the fans based on engine coolant sensor. We dialed in the temperature of 267 degrees, and the PCM would have melted that engine down and never would have turned on the fan. Still wouldn't activate the fans, even though it was seeing these engine destroying temperatures right here, and that's getting way, way too hot right there. All right. Now, we peeked into the data stream in the body computer and in the PCM, and the scan tool showed the control head was sending a request right there. Control head desired, AC on. The BCM was receiving a request, but that's as far as it went. And the BCM would not tell the engine controller to turn on the AC. That's what the BCM was telling us via the data stream, and the PCM's data stream verified the lack of a request. Okay, so this isn't a voltage deal. The connection, the communication between these two modules is a class 2 data line. GM calls it that. So You can't interpret it with a scope. It's a class 2 message transfer between modules, and it's kind of hard to track with anything except the scan tool that's talking to both modules. I went and said I'm going to reflash the engine controller. Just see what that's going to do. There was a calibration I could get for it, so I went on GM's site and I pulled it down and reflashed it. Whenever I got done with that, now using the Cardac programmer to do it, it was getting personal. Didn't change anything when I reflashed that thing. Identifix was our next stop, and post on this problem reflected issues with the BCM, PCM wire, and so on and so forth. Well, I didn't notice any silver bullets. I just saw some foggy stuff. All right, so there's 4 electronic boxes that interact in this AC cooling fan thing. The AC control head, the HVAC programmer, the BCM, and the PCM. Always interesting to me how General Motors, even on the old 71 Cadillac the president of the college had, they had this great big box with all of this stuff on it over here in the right hand side of it had automatic temperature control. This huge gigantic thing over here, they called it the HVAC programmer when it was gigantic. And this thing right here basically was just a little box, this little HVAC programmer here. The AC control head was sending a request. The BCM wouldn't cooperate with the request. The HVAC programmer wouldn't tell the PCM to turn on the AC. The PCM wouldn't turn on the cooling fans. But with the BCM disconnected, the cooling fans would come on. So that was interesting. So GM replacement BCM was $400. That was a non-starter. Salvage yard BCM was $45. So I went by on the way home and I picked one up. And they charged me $45 for it, and I brought it back. It was all installed on the next day, and nothing had changed. Now the BCM and the HVAC programmer is real close to one another behind the glove box. All right, this is the HVAC programmer. This is the BCM. See the way they look very similar, but they're not exactly the same. The PCM, the BCM, suppose the salvage yard had handed me was the HVAC programmer. They gave me one of these thinking they were giving me one of those, and I changed this out, but that wasn't what the problem was, and that's not even what I went to buy at the salvage yard. So I had to call them back and say, hey, you guys gave me the wrong box. I need the other one under there. So they said, no problem, come by. So I swapped it out, and it's got pink connectors, the BCM does on that particular car. All right, and so I plugged the replacement BCM, and everything came back online. The AC worked, the cooling fans began to operate, the trunk and jar warning light went away to be replaced by change oil soon, which we had never seen before. So there were some issues with the BCM on that. All right, we got the right part, 216 degrees, low speed fan would kick on. You know, if you let it keep warming up, that would, you know, high speed fan would come on, but typically that one there is all it needs to cool it down, you know, to cycle the, and, you know, like I say, whenever you see this thing, if you hear the cooling fan kick on, if you don't have the air conditioner on and you're warming one up, if that cooling fan kicks on and it doesn't kick off, it needs to kick off and on like 4 times. If it does not kick off and on, and it just, you know, the engine keeps getting hotter, the fan keeps running, you got a problem somewhere you need to be dealing with. If you wanted a brakes check for pulsation, the transmission had a harsh 2, 3, and 3/4 shifts. It would stall sometimes during parking lot maneuvers, and the mill was on with a MAF code we had not previously seen on this car. So we hadn't seen this before. This was another curveball. So the PCM data stream showed MAF readings about 1,000 hertz lower than normal. And so we got our $200 mass airflow sensor from the parts store. That fixed the transmission, and there was no more stalling. That wasn't the first time I had seen one of these GM cars have what felt like a transmission problem. It was ugly, but it would turn out, you know, you'd think the torque converter was staying locked and it would stall in the parking lot and all. And I've seen mass airflow sensors cause that on these vehicles before. I saw one on an Oldsmobile. The guy genuinely thought the transmission was fried on that car because his wife had thrown it in park while it was still moving or something. I don't know where he got that idea. But we found out that all it needed was a mass airflow sensor. There wasn't anything wrong with the transmission. So somebody probably had this no AC, no cooling fan operation problem, and before they traded the car into the dealership over there. And the owner had only bought it a couple of weeks. That relay had been replaced, probably trying to fix the problems that we're talking about. They replaced that fan relay. So these tough ones can work us over, you know, and we're always smarter when you come out of a fight like this than you were when you went into it. And so it's a good idea, you know, if you notice, the ones that beat you up are the ones you always remember, or the ones you fix real easy, you forget about them really fast. and that's basically the way it works for me too. I wanted to show you one more thing. A lot of you guys have seen these, you know, these pulse sensors that you buy. Okay, I got this funky little scope that I bought. It's just a cheap little scope, you know, that's like $53. And I just bought it to play with, sitting here by a computer. All right, you can buy these things, these little pickups here. I think they're $7 for 10 of them. All right, so I want you to watch what happens when I put this pickup. And this is basically an acoustic pickup, like for a musical instrument. But you put it inside a, you know, you basically pinch that thing. See how it's making, I'm pinching it, and it's making a pattern. Now, you know, I got the voltage set on 200 millivolts per division, and I got the time base set on 500 milliseconds. You can see those readings if I can get that stupid camera to focus on the screen. But the point is, you can also tap this on something, and it will give you a little, see that right there? Now this scope is not reading as fast as a regular scope would, but you get the point. All you got to do is put a little bit of pressure on this. All right, now you get one of these things. They don't cost hardly anything. All right, and what I did, and if I'd have thought about what I was going to do, I would have showed you. I actually took a 1/4-inch pipe to 3/8 hose fitting, and I drilled a hole in the bottom of a pill bottle, and I screwed that, you know, that pipe thread's tapered. If you got the hole at the starting size of the pipe threads, you can screw it in there and it'll seal real good in that plastic. And on the other end of it, I used a BNC connector, and I soldered this little thing. See, this is basically this little piezo sensor right here. And like I say, it doesn't cost very much. You can buy them for like almost nothing. All right, so you can build yourself a pulse sensor. Now your chamber that you're suspending this in, you need to suspend this in the chamber so it won't swing around and hit the sides of the bottle. And you need to put, you know, maybe if you put some bubble paper or something in there to glue it so that it couldn't move around inside the bottle. But my BNC connector's in the top of the bottle, and I basically have it, I can hook it directly up to my scope with a little BNC cable like this one right here. Put a BNC on both sides, and then you have a pulse sensor. You can put a hose in your exhaust. You'll see little wiggles. You got to set your scope up really sensitive to read it. You can hook it up to the dipstick and see if you've got pulses inside the crankcase coming past rings or piston or whatever. You can get you an adapter and put it on your radiator. So this pushing the, you know, if it pushes pressure up, you know, watch how it builds pressure. You can actually measure your cylinder pressure waveform. If you get an adapter, you know, like I've got a, you can take one of those adapters, like a adapter like what comes with a compression gauge, and you can put it in there and hook it into that same chamber. Now the chamber, there's got to be a pill bottle that'll handle the pressure pulses. If you try to pull it in a little box that's got flat edges, all it's going to blow it apart. But you can build a pulse sensor using one of these things, and it's extremely sensitive, it's extremely responsive, it's a whole lot better. I built the first one of these I built it using a that sensor for the exhaust back pressure on a diesel, and I actually got a little 5-volt power supply to power it up. This doesn't need a power supply or anything. It just hooks directly into your scope, and you can get a pattern using it to pulse. And so they don't cost very much to buy these. You can go on Amazon and you can find these little acoustic pickups like this. And this one here, I bought this little bag of them right here. It's Louvet 12 pieces piezo pickup, pre-wired, 27 millimeter. And all right, let me see if you can freeze that and read it. I got this on Amazon. I got a bunch of these in that little pack for that, and that will keep you from having to spend $500 on a pulse sensor. And you can build one for the exhaust, or you can use it for the exhaust, or you can use it for just anything you would use a pulse sensor for. Anyway, that's a little tip. What I'm always thinking about is if you build one of these and you don't spend but a few dollars building it, what does it matter if you didn't get it to work right? But the ones that I built worked really smooth when I was fooling with it on my Explorer. You know, I made engine skips and stuff. I pull in injectors and looking at the exhaust and all that kind of thing. But anyway, I'll go ahead and wind this up, and I really appreciate you guys listening. I hope you got more out of this one than you did that last one. I didn't have a lot of views on that last help desk video, which I didn't know. I don't know if it was because there weren't pictures or whatever, but maybe you can sink your teeth into what I just told you on this one a little bit better. Let me know if this is good stuff, and I'll talk to you next time.